All right, this video, we're going to take a look at the surface area of a pyramid or a cone. Now, this is surface area of a pyramid or a cone. So when we're looking at surface area of a pyramid, now we just got to think about it. Is how many, we're really just adding up the area of all the faces, right? So the base face, we have the area of that base. So we need to have that area. And then we have to figure out the area of the different faces on the sides. So whatever is the base, the other faces would be considered the side, right? So this triangular pyramid has 3 sides and the base, making 4 total faces. And so here we know the area of the base, we can find that. We're going to be able to calculate that. They'll give us enough information to do that. And then the lateral area, right? So the surface area is all of the bases, but the lateral area is what is on the sides. So the side faces would be considered the lateral area. So you can add up these side faces to get the lateral area. And when we do that, they're like, if we're going to do that for a square pyramid, for example, or any sort of like a pentagonal pyramid or a hexagonal pyramid of some sort, you're going to find the area of the base and then add all the lateral area. So however many faces you're going to have. Since this base had 4 sides, the lateral area is going to have 4 faces. Now, what's really nice about a pyramid is that all the faces are going to be triangles, right? So what we need to know about triangles in order to find the area of a triangle, right? Remember, it's 1/2 base times height. Well, here, that height is going to be called the slant length, right? The slant length. The slant length on one of these side faces goes from the point at the top directly down and meets at a 90-degree angle. So it's going to be perpendicular with the base itself. So we get this slant length that goes along the face. Do not be confused with the height of the pyramid. Remember, the height of the pyramid goes through the center to the top. That's the height. A slant length is the distance from the point at the top, and it goes down the side to the edge, right? So the slant length and the height that goes through the center are 2 completely different things, and I want to be really careful with that, okay? So slant length will help us out a lot whenever we're trying to find the lateral area to help us find the total surface area. And very similarly, when we're looking at a cone, right? For a cone, to find the surface area of a cone, we need to find the surface area of the bottom, and then we need to find the lateral area around the sides. Now, whenever we pull this out into a net, it looks like a really strange, weird, circular, it's weird. It's very, very strange. So we're just going to rely on a formula for this one. I could go through and try and show you how we create the formula and all that other stuff, but I really don't want to confuse anybody. So all I'm going to do is I'm going to give you the formulas for pyramids, for regular pyramids, and then I'm going to give you the formula for cones, all right? Surface area is going to be the area of the base plus the lateral area. Remember, the lateral area is the area of the sides. And when it comes to a cone, it's a very special formula. And whenever it comes to a regular polygon pyramid, it's going to all be the same kind of thing. Area of the base plus the number of triangles on the sides, okay? So let's hop to that part of the notes here. Surface area of a pyramid or a cone. Pyramid or a cone. So for a regular polygonal pyramid, it's going to be equal to the area of the base. Remember, that's big B. Big B stands for area of the base plus our lateral area. So I'm going to go lateral area like that. Now, remember, the lateral area is going to be made up of different triangles. Okay? So each triangle needs to have a, quote, base times height, right? So one triangle is going to be the slant length, which would be, excuse me, I'm going to start here. it's going to be the side or the edge length of the base of the bottom times the slant length times the number of sides, all divided by 2. All right, so this is the base length. So the area of the base plus the lateral area. This is for, oh, this is not for one triangle. This is the total lateral area. Sorry about that. Lateral area. I got ahead of myself. So sorry. So the base length times the slant length times the number of sides, all divided by 2. Base length times the slant length times the number of sides divided by 2. Here's what I mean by that. If I'm looking at the base of a pyramid, so I have a regular pyramid here, just so happens to be a square. It could be a pentagon, or it could be a hexagon. It doesn't even matter. As long as it's a regular polygonal pyramid, okay, we're going to take the length of the base, so the length of that side right here, so I'm going to call that the base length, and we're going to multiply it by the slant length right here, that slant length, so that divided by 2 would be 1 triangle, right? So that lateral area, 1, would be that 1 triangle times the number of sides that the base has. So for a square pyramid, the base length times the slant length times 4, because it has 4 sides. That would be the n value, okay? And then all that divided by 2, because the triangle is divided by 2. Okay, so let's piece it all together. Yep, there we go. So the surface area, the total surface area, is going to be the area of the base plus b times slant length times number of sides, all divided by 2. Okay? If it's an irregular pyramid, draw a net. So I'm going to make a note here. Note. For irregular pyramid, draw a net. And that's an exclamation, like, draw a net, woo! You know what a net looks like, so do a rough sketch of a net, because on an irregular pyramid, you can imagine that the triangles are all going to be of different, there's going to be different sizes of those triangles on the side for the lateral area, okay? So draw a net and just take your time and go slow. All right, surface area for a cone. The surface area for a cone. The surface area is equal to pi r squared, so that's the area of the base, plus the lateral area. Now the lateral area is pi r L, which is slant length, right? Remember, L is slant length. So note, L stands for slant length. I can spell today. Okay, let's take a look and do a few examples here. First example is a cone. Okay, so this cone, remember, the surface area is pi r squared plus pi r L. Remember, L for slant length. Okay, so here is your area of the base. Here is the lateral area. Now, this asks us to find the surface area and the lateral area for this cone. So we might as well start with the lateral area, and then we can add the base and find our total surface area. Okay, so pi r L. Now here, it gives us a diameter of 16 units. So that means that the radius must be 8 units, right? Take the diameter, cut it in half, and there you got your radius. So I can start here. My lateral area is pi r L. In other words, it's going to be pi times 8 times our slant length of 23.4. And when I plug that in my calculator, I get, we're using 3.14 for pi times 8 times 23.4. It is, oh, what did I do? Oh, excuse me. Okay, it's 587.8, we'll call it. So 587.8 units cubed. No, squared. This is area, Steven. Let's get your head. Get your head in the game. All right, so that's our lateral area. That's just this piece here, the lateral area. Since the directions asked us to find the lateral area of this cone, we have 587.8 units squared. Now let's find the total surface area. So I can get pi r squared is going to give us pi times 8 squared. And when I do that, 3.14 times 8 squared, 200.96. So that is 200.96. Now my total surface area is going to be that 200.96 plus 587.8. When I do that, we get 788.76. So the total surface area is 788.77, 88.76 units squared. Sorry, this was squared. So that my surface area, and there is my lateral area for a cone. All right, let's do another example. Ooh, so here we have an irregular pyramid. I don't like the drawing. I don't know, whoever drew this needs to get a better day job because they cannot draw. So it's irregular. Let's draw a net, okay? So let's start with the rectangle in the middle. So there's our base. And it's going to have 1, 2, 3, 4 triangles that go off the sides. So 1, 2, 3, 4 triangles that go off the sides, right? So what I do know is that this distance here is a 14, this distance here is a 33, and the slant length here is a 24. So just thinking about the total surface area, I have the rectangle and 4 triangles, right? So before we get to all that, let's do just the lateral area first. Then we could do the base and add that with the lateral area, okay? So I know I have 1, 2 of these triangles, and I have 1, 2 of the smaller triangles. So area of one triangle is base times height, right? Base times height divided by 2. So the let's call this the big triangle. So for the big triangle, our base is 33, our height is 24, so we get 33 times 24. There should not be a dot right. So 33 times 24 divided by 2. That will give me one big triangle. And then for the little triangle, my base is 14. And remember that distance right there, it's going to be the same, right? It's going to be the exact same distance. Hang on. I'm doing a lot of thinking here. I don't think it is the same distance. I don't think it's the same distance at all. I think it's a completely different distance. Oh, wow. Wow. In fact, that distance, I can't believe you've done this. This is impossible. Wow. Made a whole entire video where this part was impossible. That's really annoying. Oh, man. Huh. That is particularly annoying. Yeah, I don't know that we're going to be able to find this one. So this one, unfortunately, is not possible. Huh. I'm sorry about that, y'all. I didn't mean to waste your time. Let's do the third example and just call it a day, huh? Everybody makes mistakes. How cool is that? What a cool little lesson we just had there. I did some learning today, and I'm going to not make any edits and just let you guys realize that I did some learning. All right, here we go. This is a regular pentagon or pentagonal pyramid. So this is a regular pentagonal pyramid. All right, now this one we can do. This one we can do. So the area of the base, okay, so it's going to be the total surface area is area of the base plus our lateral area, which is all these 1, 2, 3, 4, 5 triangles. So this part here, we have 5 triangles, and this one here is a pentagon. All right, so we can start off with our lateral area because the directions ask for lateral area, and then we can find the area of the base with the pentagon, add them together to get our total surface area. All right, so for the lateral area, so their lateral area is going to be 5 times 1 triangle. 1 triangle. So one of these triangles, the base is 8, the height is 10.6. So we're going to have 8 times 10.6 divided by 2, right? The area of a triangle, base times height divided by 2. So one triangle is 8 times 10.6 divided by 2. Multiply that by 5 to get all 5 of our triangles here for the lateral area. All right, so I can do this in my calculator. So I get 5 times, I open up parentheses, 8 times 10.6 divided by 2 is 212. Oh, that worked out real nice. Thank you for that. Equals 212 square feet. Now the area of the base, Now remember, a pentagon is the base length. So here we have 8 times the apothem, 5.5 times the number of sides divided by 2. So our base, just the base itself, is going to be 8 times the apothem here, which is, and I'm going to put this in parentheses, 5.5 times the number of sides, 1, 2, 3, 4, 5 sides, all divided by 2. Now we can do it in our calculator. So we have 8 times 5.5 times 5 divided by 2 is 110. 110 feet squared. And now our total surface area is going to be the area of the base, the 110 feet, plus the lateral area, 212 feet, for a grand total of 322 square feet. So our surface area and our lateral area. Sorry for that weird mix-up there, but I'm glad we all learned together that an irregular polygon is a little bit more difficult, or irregular